Well, I'd like to welcome everybody to Delphi's Tech Tip Thursdays. Today's topic is tips for completing drive cycles. I'm Rick Escalambre. I'm excited to be able to present this information to you, and we've got a lot of information to cover in an hour, so let's get the show on the road. First, I'd like to say that tips for completing drive cycles is not listed as a three-part series, but in May, we're going to be doing Operation the Good and Bad of Mode 6. And in the third series in June, we're going to be doing Mode 9, in-use performance tracking, and we're going to kind of pull all three of these together in that last class to show you how to use this to your advantage. So let's get show on the road. What are we going to do in this next hour? For next hour, we're going to work on what we call developing a drive cycle plan. A lot of misnomers out there about the word drive cycle. I'm going to clear those up. If you notice on the second one, it says what should be checked when preparing to run monitor tests. We're going to explain what a drive cycle is and what monitor tests are and how they all fit in together. What a PID 41 is, you may have seen it on your scan tool, and that's where when you go in to look at monitors, readiness monitors, and you see since last cleared, since 2008, there's been a second option called monitors this drive cycle. This is a hidden gem. When it works, and it's not that the system, the way it was designed, works well, it's how it's handled within the scan tool. I'm going to show you some examples of that because that can be a time saver for you too, especially if you don't want to clear existing readiness and maybe you've had a DTC and you want to drive it out. This is the way to do it. I've been doing drive cycles since 1996. That's 30 years now. We were fortunate enough at Skyline College to have 4 dynamometers, and I'm going to go ahead and take myself off the screen here a second. Don't need to tie up the screen doing that. And we're going to give you my theories on some generic drive cycle information that can help you when you don't have any other thing to fall back on. We're going to talk a little bit of parallel monitor and a little bit on samples and counts. But this is all leading into the next workshop, which will be Mode 6. And I think Mode 6 is a gem when it works. And I think you need to know the good and bad of it. So we'll tie that together. Okay, so I battle this around the country when I'm dealing with this topic. California, everybody, so you're from California, you're in a emission state, it all means something to you. And finally I came to the realization that yes, that's true, and yes, we have, I believe, 26 other emission states with emission programs, but I came to the realization it's very simple. Basically, if you're performing emission repairs because the mill is on, you are an emissions tech. Even if you don't carry that title officially, you haven't passed a test for it, you don't have a license for it. If you are fixing that check engine light, you're an emissions technician. And so when that light comes on, it means that federal test procedure, the predicted tailpipe emissions have exceeded federal test procedures by 1.5 times the standards. So we're trying to go to get that check engine light out. And there's a couple simple rules I like to follow. A good friend of mine from the automotive industry named Chris Chesney, he said this years ago, and I've always remembered that. As a repair technician, who are you working for? It depends on the rule of the game which you are playing. First, the vehicle failed an OBDII state emissions test, which again, that's half the problem. The other half is the mill is on. And that's what a lot of you deal with on a regular basis, even if the vehicle is not in for an emissions inspection or you're not in emissions state. So this is the first step to ensure a successful repair. Okay. The next thing is, if the vehicle owner has a drivability concern only, no mill, then you're working for the vehicle owner. Simple as that. You've got to satisfy them. If you're not satisfying them, then you're gonna have concerns. They're gonna have concerns. If the only concern is the mill is on, then very simply, you are working for the PCM. Okay, keep that in mind. You are working for the PCM, because if the PCM's not happy, you're not going to be happy. If you don't work for the PCM, you risk not satisfying the owner. You risk possible blocking conditions. And if this was a longer class, and I'll show you this a little bit in the follow-up classes, what blocking conditions I mean. But it means knowing your numbers and knowing what consists of criteria for that system and where the numbers might be falling out of range. It could be another system on the car that's blocking. We're going to talk about that a little bit later. You risk the chance of making unnecessary repairs, and most importantly, you increase your chances of comeback. Okay, so keep a plan in your mind and who you're working for and what is your objective. Again, the mill means you're working for the PCM. Now, I want to throw this in there. There's nothing, no monetary gains on this site. I know a lot of you found it already. I'm very proud of it. It's no cookies, no cost. It's free for you to use. I'm constantly adding stuff. It's just content, getting content on a website takes time, especially good content. I have downloaded some stuff. One thing I do want to mention is new website content. If you've been there before, I recommend you go there because when I make changes, now I put them in there like a TSB. So it'll take you to the latest changes I've added to the site. There's a lot of information in there from computer controls all the way up to the Unified Diagnostic Services, which is going to start full-fledged in the 2027 models. They're already out there now, and we're going to need to be aware of that. But I just encourage you to use it. You can reach me through that website. I'm here as a resource for you. And a lot of the stuff we're talking about today, not all of it, but a number of it is there. I also have my YouTube videos, and I have some industry resources in there. So please look around, see what's comfortable for you and what can help you. That's all I'm concerned about, and that's why I'm doing it. Been in the industry 53 years. I've been working with OBDII since 1996. I've trained over 10,000 technicians in OBDII, and I've made it my goal to try and make you better techs when it comes to global OBDII. And with the new system coming out, it's going to be very important that you have good background in global OBDII to be strong in that. Okay. We always want to establish 4 things that are very important. Anything we want to do with verifying a repair and using the PCM to do it. So let's go over some fundamental terminology. A warm-up cycle. Warm-up cycle you can see on your global scan tool. Some OEMs will show it, but most of the time it's in your global scan tool. And what it basically means is wherever you start your engine up and the starting temperature of the coolant sensor, as long as it's below 159 and it crosses 160 and it rises 60 degrees, rises 40 degrees and crosses 160, that's considered warm-up cycle. So if you start at 130 and you stop at 159, that's not a warm-up cycle. If you went to 161, that's not a warm-up cycle. If you started at 90 and went up 69 degrees to 159, that's not a warm-up cycle. Now, why do we use warm-up cycles? The PCM uses it to clear any existing DTCs that were left in memory if the issue has not reoccurred. The thing I want to emphasize is a warm-up cycle does not require a cold startup. So it's basically the computer's way of tracking how long any information has been in memory. It's also your way to know if somebody has been in the system before you got your hands on it. I'll show you a little sample later, but if you go in there and see 1, 2, 5, 7, somebody's been in there, or maybe they've had a dead battery, but somebody's been in that system. That's a clue that you're not getting this car firsthand. Okay, cold soak. The ECT and the IAT temperatures must be within about 10 degrees of each other, and that's an average of what I've seen in the industry, and they need to be below 122 degrees. Where do we typically use it? Some O2 heaters, and we're going to go through O2 heaters testing a little bit today, require it, some don't. Secondary air, almost all the secondary systems that I can think of require a cold startup. And it's usually only very effective in the first few seconds of the startup. Evap, some do, some don't. For cold startup, this is mandatory for evap when you're doing vacuum decay, but some of your key-off systems don't rely on that anymore, and because they're doing preliminary tests with the engine warm, and then they're finishing off with small leak detection when the engine's off. Enable criteria is what makes this so hard. If enable criteria had been standardized of some kind, we wouldn't be meeting today. We would have cured this problem 28 years ago. But enable criteria basically are the conditions required for a DTC-related monitor test. In other words, every DTC out there has enable criteria, conditions under which they will judge the test for a pass or fail. We need to be in that window for the PCM to be able to do what it needs to do. The problem is they all pass a certification test through CARB EPA, but when it comes to running them in the real world, they kind of set their own time frame as when they want to run it. Okay, and the last one, trip. It requires a key off and key on, engine off, where you might just turn it on and it might do a TPS circuit check. It might do a coolant sensor check. And after a period of time, it judges if it passes or fails. But a lot of your other tests, you have to have key on engine running. You have to meet certain criteria. And once you meet that criteria, then that's considered part of a trip. But remember, a trip does not end until you turn the key off And I always say a minimum of 10 seconds, but the simple way to remember is if your scan tool says no data available, that trip is ended. If you don't do this and you start the key up right away, you turn it off, and within a few seconds you turn it back on, the PCM hasn't gone to sleep, you're going to be wasting your time because you are in the previous trip and you may have hit the maximum time already and you may have exceeded the criteria at that time. You can't make it work. So keep these 4 things in mind. We're going to use an example here. This is from the Ford OBDII free resource site that's been around since 1996. The example I want to show you here, because it's the best one I can think of to show you, is we have a P0133 here. What I'm looking for in my criteria is what I call once per driving cycle. Basically what that means is this specific test must run and complete to be able to flip the flag, the readiness flag to complete. We're going to talk about that a little more, but this could be where I'm looking for a blocker. I may have run a bunch of O2 tests, but the O2 is still incomplete. If I go look up the criteria for a P0133, I find that this is the one that's holding me up. Okay, now you always want to take a look at sensors, okay, and also no conflicting DTCs. Example of this one I'm going to show you throughout this series is EVAP. In this particular case, is an issue. It can keep the O2 from running. I'm going to have a case study in a later class to show you where a customer spent $4,400 before we got a look at it and saw that it was a $300 job that was preventing the monitor tests except for EGR from running. Very simple, and we followed my procedures. I diagnosed in about 10 minutes, maybe 15 because it was a pre-OBDII car, what the issue was, and we got it down real quick. But prior to that, $4,400. Okay, and the last one at the bottom is important. When we start running monitors, drive cycle tests, the tests themselves don't take very long. I've seen 40 seconds. I've seen a minute on some. I've seen some Toyota early EVAP systems take an hour. But as a whole, when we run monitor tests, the actual test itself is only for a very short period of time because they don't want an intrusive type situation where the customer is going to feel what's going on. So they're going to take a sample. Some cases, they might only need 1 or 2 samples. In other cases, we're going to talk throughout the classes that they may need multiple samples. And this is why you've done everything right and you're wondering why it's not completing. It might be in what we call an averaging mode, and it needs multiple drive cycles to establish a pass or fail. And it may be a pass, but some manufacturers use what we call EWMA, exponentially weighted moving average. And they basically are taking multiple tests, filtering them out, average them, and then issuing a pass or fail. We don't want to have any false passes. We don't want to have any false fails. So this is one way of doing it. The other site, and both of these are on my industry resources on my page, and you can get them in the industry out there too, is this is the GM one. Every manufacturer who certifies a vehicle has to turn this into car BPA. There's a chart like this for every DTC. Unfortunately, GM was the only one that has made it public. And thanks to a friend of mine, I've seen Audis, and Ford has these. I've seen that from CARB, but they're not published. Yes, they're a little bit more engineering data, but when you have this available, and again, this is free. It's available to you based on the link on the bottom of the page or and the links on my website. It tells you the parameters and it tells you the enable conditions. And sometimes you got to sort through these. And you got to understand the system a little bit. So that's why we're going to talk about generic information so that you have a good starting point. And then also the word samples. Whenever you hear the word samples, whether it's pass or fail, it means it might need multiple tests to make a judgment on that. So it's like taking an ASE test where you have 1 pass or 1 fail, period. Wouldn't it be nice if ASE said, come on in, we'll give you 5 tests, we'll average them out, and we'll make a determination whether you get your certification. Unfortunately, ASE doesn't do that, but on our cars that use exponentially weighted moving average, they do. And it can be a passing vehicle, it can be a failing vehicle. So just be aware of that sometimes you get in a mode, and this is what we're going to develop over the 3 classes to show you where it may have run, but it's not ready to pass judgment yet. Okay, the other place you get some good information is your freeze frame. If the cars come in with a mill on, save that freeze frame. My experience has been about 98% of the time you see the freeze frame, that is the enable criteria and the conditions under which it's set. But to get out of trouble, that same conditions are still used, but the couple cases like Nissan mass airflow sensors, if you set them, they have a different criteria to get out of them. But in 98% of the cases, if you can use this information to get your engine speed, your coolant temp, Was it warm? And what I mean by coolant temp, was it below 150, 160, 159 and below? Was it 160 and above? One's a cold side, one's a warm side. Two different spectrums, two different conditions. Vehicle speed, calculated load, or it could be absolute load, depending on the car. The idea is, this is what's the hardest part to pick up in drive cycles is, what is the load? What is the right amount of load? I can drive going up a hill. I can coast going down a hill. I don't always have to be on a flat road, but there are conditions I got to meet, and the freeze frame can be an excellent place to do it. So with whatever scanner you have, whatever smartphone you have, take a picture of it and save this information, because that's how you're going to want to drive the vehicle to verify your repair. Okay, another thing I want to clear up is the difference between a readiness flag and a monitor test. Readiness flags are what we use for emissions inspections. That's also what we use to know if the system is done testing. So if it's catalytic inverter and it says complete, it's telling us in 2008 and newer, we are done testing the system. If there's no MIL, no pending code, then the system is passed. The thing is, though, those are not monitor tests. Those monitor tests make up readiness. So if someone calls me, and I get a lot of calls on this, I can't get this monitor to run, and particularly the O2 is an example, evap is another one, and they'll say, I can't get it to run, and I'll go in and look at mode 6, and I will see that a bunch of tests ran, but it hadn't finished. So whatever they were doing was right, they weren't finishing off. So the readiness flag would stay incomplete. The monitor tests were not all done. So when they're all done, then the readiness flag can flip to complete and sign it off. Prior to OBDII, complete could mean it was done, it passed, and incomplete meant it didn't finish, or it could have been that it failed. So we have to be careful of this terminology. Now, one last thing before we move on to the meat of this. This is a little chart I'm going to use for the 3 classes. Not only verifying status, but in the 3rd class, we're going to use this thing called in-use performance tracking. In the past, we've never had a way of checking the vehicles when they come into your shop to know what their history has been for running monitor tests. And so this has been a way, a quality control check that CARB EPA put in to allow people to see what the history has been when it works correctly. There are times when it doesn't work correctly and it can be misleading. But it was designed for quality control for the companies, but I found a way to use it for you, to your advantage. The other things we'll be addressing in this will be things like that classes will be mode 6, and we're going to talk about averaging, where you could be in an averaging mode and you're not done, and you're going to have to maybe run this thing 3 or 4 more trips to get it to establish a pass-fail value. So keep that in mind. This is a little chart that's on my website too, and we're going to break this down over the 3 sessions. Okay, drive cycle plan. To be successful when running a drive cycle or individual monitor test, the technician needs 3 things. A plan, we call that our enable criteria or a drive cycle. The enable criteria, to me, is more important than the drive cycle. Remember, a drive cycle means you turn the key on, you ran all the monitor tests in one key cycle, one trip, and you turned it off and they were done. For most people, that's not realistic. If you have a dyno, that's more a possibility to get them all done in one trip. Generally, what you're trying to do is go out and verify a repair on one system, maybe the EGR valve, and you want to go out and make sure the PCM's happy with us. You take it out and you drive it. You do it in 5 minutes, EGR is done. You come back to the shop, and in the process of doing that, the VVT and maybe the O2 ran. That's okay. Nothing wrong with that. You went out to verify your repair, and in the process, it ran some other individual monitor tests. Driver patience. You cannot speed these up. There's no software out there to force monitor tests to run. You need driver patience and understanding. And the last one, you need a reasonably steady throttle in most cases, but not all. And I'm going to show all these to you where you would vary those. Okay, so we call the plan a drive cycle, but I want you to remember that drive cycles can be broken down individually. I use a lot of patterns. I'm going to show that to you coming up. I got rid of patterns. I stopped doing those because techs would say, hey, I followed the pattern and it didn't run. It didn't do this, or it ran out of order. We're at the mercy of the PCM. It's looking at things we don't even understand sometimes. Just remember, it requires that the enable criteria for all monitor tests be run in one trip to call it a drive cycle. Each manufacturer typically provides driving instructions, but there are flaws in that, as many of you found out. It's not easy to find sometime. If you've ever gone to look at Kia, Hyundai, that can be a nightmare. Some just don't specify. And those things that I showed you in the freeze frame about load, temp, engine speed, those things are important, but they're not always included in the requirements, so you're not hitting the right window for the driving condition. That's the key. And remember this, drive cycles are different between manufacturers, and sometimes they're different within the same manufacturer. Go look at Toyota. GM's got a couple of them, 3 of them. Go look at Subaru. They've got a few. Even though Subarus are easy to run most of the time, there are some variations where they've got some differences depending on the style engine. So we don't standardize anything. If we did, we wouldn't be having this webinar today. And the most important part is you can do any part of a drive cycle individually to verify or repair or to prepare your vehicle for a smog check inspection. So keep that in mind. You want to work for the PCM. You want to verify or repair. I attune it to the fact that someone says they clean the EGR ports, and I say, how well did you clean them? They say, well, I clean them as well as the boss pays. And then that vehicle comes back because they didn't bother to go out and take a drive and find out that it just barely passed and is probably going to be back within a month or two. So the idea is there's ways to follow up on this, and this is why we're doing it. We want to avoid the comebacks. Okay, drive cycles. I have some of these on my website. We created these. Any of the ones I have on my website, I put them up there for a reason. We had, like I said, 4 dynamometers. We ran thousands of cars. Could have been the same car 100 times, but we got these down to where we perfected them. But the most important part of drive cycles is this part right here. You need some explanation. And I'm going to say to you this, never ever give the customer driving directions. Tell them to go out and do their normal driving, but do not tell them how to drive the car. Because the best example is GM says on deceleration, don't touch the brake for the EGR monitor test. Well, if they don't touch the brake and they hit a car, guess who's going to wind up in court with them? You are, because you told them how to drive the car. I put these instructions in here to kind of give you little clues as what are you trying to do. Look them over them. Think about it. Develop your own that you have for each vehicle. But this is the most important thing. Part of drive cycle monitor tests are luck. I'll be honest with you. I'd be lying if I didn't say that. But a lot of them is alleviated by having a plan and knowing what you're trying to accomplish before you ever go out on the road. This next one is a simple Subaru one. This is some software I use from, it's called Silver Scan Tool. Allows me to really get in and do measurements and analyze stuff to help make me better, to help make you better. And if you take a look here, this was a Subaru that we started up cold, the 2023 Subaru Forester. We started up cold, did all the preliminary checks, the things I normally want to check. Within 55 seconds, the O2 heater ran. Within 4 minutes, a little over 4 minutes, the BVT ran. Within a little over 6 minutes, the O2 ran. And I've got temp in here, I've got time, I've got vehicle speed. And within 7 minutes, we ran the cat. Now, no evap because this is a pump system. And the only way this was going to run is after shutdown, it's going to have to sit a while. So I focus on the 4 right here that it had. And these are pretty easy to run. But I just want to show you, when you know your plan, you know what you're doing. I didn't even have to get on the freeway on this car. So the idea is I'm using this kind of software to help me, to help you. Because your normal scan tool is lacking some of this information the way I can organize it. So some of these things, this one's going to be popping up on my website too with some other information. But I just created this one a while back and I wanted you to see it. Okay, my idea of generic criteria is something I've been using since day one, because back in 96, 97, 98, information was sketchy at best. And all the testing we did, we found what worked and what didn't work. But I like to put it in a general checklist. So when you run into, I just put a new O2 heater in this car. I want to check it. How should I check it? I'm not seeing clear information on it. I can't find it in Mitchell or AllData. Some require a cold startup. And the key is, I'm going to show you this in the next slide. Don't leave the key on too long in some cars, because what will happen is, like GM's, it can void it out. Some will test during startup, and some take a few minutes after startup, which I'll show you. Some can run at a stop, idling and drive. And that same vehicle I'm going to show you will run it at cruise, depending on how you started it up, what temperature it was at. An engine ignition to be off on some Chryslers, as Chrysler did for a lot of years. They would test with the key off. And if you had an aftermarket scan tool, you didn't know what was going on. If you had a factory scan tool, you could hear it beeping at you, telling the O2 heater test was being done. So let's walk through this on the next one. This one right here is off a GM. I can go into the OE side of the scanner, cold. I can turn the key on, and I can watch the O2 heater in action over here and know that that test is being run. And shortly after that, I'm going to get a complete. Whether it's a pass or fail, I don't know until I get the results. But this is one of those that requires a cold startup and a very specific criteria in the very beginning. Some of them you start up, let idle. Some you start up and you got to get into a certain fuel trim cell and it will run. This one here was off of Toyota. And if you notice, we're up here at cruise right now. This is a high-speed cruise. And this orange one down here is the O2 heater. So the CAT is run, the O2 is run, and the VVT is run, and the O2 heater is actually running last. So the other thing I want you to get out of your mind is this thing, there's orders to this. This is where patterns can be deceiving. This was the cold engine, the heater ran at cruise. Okay, now this one here is the same one, same vehicle, but notice, I took it out, I recorded all this, I pulled it over, I shut it down, I waited a few minutes, I went on the freeway, and you can see the CAT, the O2, and the VVT ran, and notice that the O2 heater ran here at idle when I got off the freeway at a stop sign. So the idea is just keep this in the back of your mind that they can run at different times depending on the criteria, and it depends on your startup temperatures. Okay, so pay close attention to that. Am I starting it warm? Am I starting it cold? Oh, it's not cold, I can't run them. Yes, you can on some cars. Many tests will run when the engine's warm. You've got to know your system. Then on this one on the right, this happens to be a Nissan. And I'm going to blow it up a little bit because it's right on the edge of the screen. I try to squeeze a lot in the screen. This is the Nissan right here. And right now, if you take a look right here, it says this is the engine RPM. Right here is when the key was on and engine off. Well, if you notice, the O2 heater is complete right here to the left of this line, which means I just turned the key on. In a matter of seconds, that O2 heater ran and it passed. Okay? And shortly after that, the engine started up. So sometimes you have them where you only have to have the key on and it can do it. And if you've ever done Hondas, generally with Hondas, it's the first one to run. And it's generally from 5 seconds to 25 seconds after startup. That thing is done, complete, ready to go. Okay, so know your system, because if you're going to put O2 heaters in the car, make sure you verify that the PCM sees what it's supposed to see. Okay? Now, generic for oxygen sensors, air fuel sensors. Again, if you have no other criteria, most of them run between 15 and 55% throttle. Now, I gave you that big range because it will run at different loads. What we don't want to be is at 60% throttle, because on most cars, 60% throttle is considered by the PCM to be under wide open throttle conditions. You can see that in your calculated or your absolute load. 55% and below is where I want to be. The most important one, that third bulletin, when you're trying to run oxygen air fuel sensor test, generally you're looking at about 2 to 3 minutes because there's a warm-up time. And think about yourself. If you're trying to warm up a catalytic converter and you were in your stall, you'd either power brake it or you would take it up to 3,000 RPM and hold it there for 2 to 5 minutes, and you would assume that the exhaust was hot. Well, the PCM does that for you, and I'll show this to you in a video later, how the PCM does that. And all cars are doing that. They're inferring that the exhaust is hot. And in global OBDII now, in CAN cars, you can see the inferred temperature of the CAT on the scan tool. We'll see that a little bit later. Some air fuel sensors, oxygen sensors, some will run at idle while in drive. And we're going to see a little later, some might require light acceleration and light deceleration because you're the active fuel management. You make it a little rich, you make it a little lean, and you Humpty Dumpty it, as I'm going to show you. And that's how it judges whether the thing is working correctly. Okay. General catalytic converter, same as the O2. Less than 55% off idle in most cases, but not all cases. Less than 55% on the calculated load and absolute load. Mass airflow, a good window, 15 to 35, but depending on the engine, it could be higher. I've seen them go higher than that. If you have a standard map sensor that's basically a 0 to 5 volt range, somewhere in the 1.5 to 2.5 volt range is a good load if you're trying to calculate out load. And think about this, a number of cars have gone back to map sensors. Now, if you're on a Honda, that's not going to work because Honda's tops out at about 3 volts. So you want to be about a 1.25 to 1.75 volts on a Honda to be in that window. Otherwise, you got too much load. Once again, they infer temperature of the exhaust. Look at your global scan tool. Start developing a window. My experience has been, and there's always a fudge factor in here. I usually use 800 as a window, as high as 1200. But there's a case study I'm finishing up today that I'm going to the shop, and I've got their CAT running at 1500 when it runs. Vehicle runs great. It's sitting at 1500. That GM, it seems to work fine. But this is a good window if we're in that window. And if you're at 1,1500 degrees and there's no misfire, then just accept it that that's the way the vehicle runs. But if you can feel anything, then that temperature is being inferred and there could be a little misfire going on too, but not enough to stop the cat from running. Engine RPM, ballpark 4,000 RPM max, but again, there's always a fudge factor that. Never say always and never say never. RPM windows, except for the idle cars, 25 to 70 is a good window for running cats. Again, you have to kind of figure out the car, look up the criteria, maybe from experience or maybe from a freeze frame. Find that window, find that sweet spot. But generally a converter will be a pretty steady throttle when we're testing it. We don't want to artificially enriching it and lean it while we're trying to test it. Let the PCM do that. VVT. Clear on this one. VVT passing does not mean the whole system passed. When we do the VVT monitor, there's only looking at two things. One is target degrees, which in this case, it was 10 degrees. It was almost perfect, dead on, and it returns back to 0, and the time that it took. That's all they're looking at for the VVT monitor. And most VVTs, you can run those after startup and at low speed. They don't take a lot of effort to run. I found those, and if you ever look at, when we get into mode 9, if you ever look at that, VVT cars are huge on the amount of completions versus what we call conditions, because they're not hard to run. And I'll show you an example of that coming up. Secondary air. This is your one cold criteria. Cold soaks are required. You can do manual test warm, but for the PCM to do it, it's generally right after startup. The PCM has to issue at least a 10-second command to the system to know that it's been commanded to work, and that's when the test is going to run. Make sure you get one of those. If you're not sure, generally give it a cold startup, run the test. The older GMs, some of them, you had to get it started up and get into a fuel trim cell, which could have been 500 RPM, 1,000 RPM, but you had to get into a certain window to test it. Most cars today, start up, let it idle, secondary air should run. Okay, evap. For those that like to run evap, we're going to talk vacuum decay system, which basically means the purge has to open to pull a vacuum on the system, and when it does, it's going to run its leak check. Most cars, again, we need that cold soak for that to happen. We need the temperature within 40 to 95 degrees startup. We need fuel level 25 to 75%. And in most of these cars, we don't want you to be sloshing. Sloshing the tank throws off the FTP, which makes it seem more volatile than it should be, and it may not run the test or it may false fail. Except for Nissans, who have a fuel tank temperature sensor in the tank, and they use that, and it needs to rise 2 degrees Fahrenheit, 4 degrees Celsius to be able to, flip that around, 2 degrees Celsius, 4 degrees Fahrenheit, to be able to know that there's enough pressure in the tank to test. And the other thing on evap, it's not load dependent, which means if you want to run an evap monitor hanging on the hoist, or you want to run it on a dyno with no load, it's okay. It doesn't need load, it needs speed. And the last one, they usually kick in somewhere between 140 and 170 degrees for them to begin their evap testing. Okay, so this is what I call my generic criteria. Pre-checks, absolutely got to do this today. Everybody should have some kind of scanner now capable of doing a topology check or a network check. You used to call it state of health, but remember, if you're on your global scan tool, you're only talking to two possible modules, engine and transmission. I've had already a half dozen cases recently where it wasn't in those modules. It was another module, ABS issue, fuel pump control module on a Mercedes that wasn't coded, that was keeping the O2 and the O2 heater from running. I just had one the other day, and I'm going to show this in a slide coming up. It was a hood latch. The hood latch was reporting to the PCM, and that was considered a emission issue because the hood was open and the vehicle, they couldn't look at it as running, so they wouldn't run the test. And that's the one I'm finishing up today. Transmission issues. Again, scan the bus to make sure there's nothing hidden in another computer. In the future on these new systems, any computer that has emission-related data into it has to report directly to the PCM. Where this ABS here may report to the ABS computer that's a wheel speed sensor, but what they're not telling the PCM is that's where they get the vehicle speed from to be able to run the tests. So you got a blocking condition that's not reporting to the PCM, and you got to go find it. So please, get your later tools. They all have this now. Find a way to scan the bus and look at all the networks to make sure there's nothing hidden in the background. Okay? And again, they'll do a good job of pulling this up, telling you which one has errors in it. And in this case, this is what I had on the Silverado. When I got it, he says, I haven't been able to run my monitors for quite a while. Then he finally said, yeah, I've had a hood latch switch on. And when I got in there, he had this in both confirmed, pending, and permanent codes. He replaced it. After he replaced it, the O2 heater ran right away. The VVT ran right away. We did some other work on it. Got the cat to run. And over the weekend, last weekend, he got the O2 to run. It wasn't just this, but this was one of the blockers. And then there were some other issues, mechanical issues, reporting issues that we got fixed. And I'm going to do those in a later case study in the one of the other classes. So keep that in mind. Now, when you're doing this checking and you want to run any kind of monitor test, please verify this information. Don't drive blindly. Don't fire the car right up. Ambient air, all your CAN cars, 2008 and newer, have ambient air temp, intake air temp, coolant temp. Check those at startup to make sure they're in calibration. If one of these is way off, that could be a blocker right there. So make sure you're paying attention to that. If you keep a car in shop overnight and there's a heater on, remember that intake air could heat up. I've seen them 10, 15 degrees warmer than coolant, and the car won't run its test because the spread is too great. Always check barometric pressure. Know what it is in your area. Understand it, because as it starts to drift and go up in altitude, it will not set a code. The PCM will look at this and say, hey, it's not shorted, it's not open, we're at 8,000 feet, we're going to suspend the monitor test. Always pay attention to that, because these can get skewed, but they won't set codes unless they're open or shorted. Fuel level, some vehicles, systems under 15%, they're suspending the monitor test. EVAP suspends it on some cars at 100%. So keep the fuel level in mind, and make sure you have enough fuel in there to run your test. And that's very, very important. Warm-up cycles. If you see something like this and they've come into your shop, they've either had a dead battery before they arrived to you, or somebody tried to clear it before they came into the door. Then they'll tell you, just happened. Don't know what it is. They just masked a problem that's probably been there for a while. Control module voltage, absolutely critical. Make sure you're getting proper charging system voltage, because if not, things like O2 heater test, EVAP test, key off, will not run. And your system pressure for EVAP, always check that. And I'll show you in a later class, follow-up class, what can happen when EVAP pressure is skewed at key on engine off, and how it can affect all the monitors from running except for EGR. So you got to look at these things before you do anything. This is your checklist, and then move on. And this driver seat diagnostics shouldn't take you that long. And occasionally you got to go over to the OEM side if it's a pre-CAN car to find some data that you're not getting on the CAN list. So don't exclude the enhanced side, pre-CAN and post-CAN, for some of the PIDs that you might want to look at. But for global OBDII CAN, you should be able to find quite a bit there. Okay, next one. Whoops. We've been using the one on top here since cleared, since day one of OBDII. The problem with this is once they're set, complete, the only way you can see them switch is you have to clear it. Well, sometimes you don't want to clear these things because you don't want to have to run all the tests again. So there's this thing called Monitors Complete This Drive Cycle. We call it PID 41. And it will let you know every key cycle. This one will show them as not run. And when you drive them that key cycle, even if they're complete on the top one, they're going to be incomplete here until they run. It's called PID 41. I'll show this to you. It's for these monitor tests right here. Wonderful tool. The thing on this to remember is it's in the system, but some of the scan tool companies have just totally screwed this up, or the way they present it isn't good. But there's some things you want to know about it, because when you got it working, it can be your best friend. Okay? A lot of them, when you turn the key on, you might see this under Monitors Complete This Drive Cycle. And remember, this is only relevant to 2008 and newer CAN cars. If you have a 2007, 2005 that's not CAN, 98, this is no good. Does not report this way. Why do they show not complete or it's not supported? Because you need to make sure when you're using monitors this key cycle, you need to start the car up. They will not give you an updated status until you start the car up, and that will refresh it, and it will update it to not complete. And then when you drive with that key cycle, you can verify your repair. So you just repaired the EGR. It's already complete on one side. You don't want to clear anything. You just want to make sure it works. Or maybe you want to drive it a few times to get the light to go out. Do it through PID 41, and see what it does this key cycle. Okay? And there's another thing in that same PID 41, there's a thing that'll tell you that they're disabled. In this case, the evap was disabled because of temperature. The engine was too warm when it started up. And for most cars, that means evap is not going to run that time. This happens to be a Nissan, and I ignore it because I can run Nissan almost any time I want, any temperature I want. There's one other one I draw attention to up here. It says the O2 sensor monitor is disabled. On all the other cars I've ever seen with this, it's not going to run. If you run in any Nissans where it says disabled, when you start it up, hold your breath because I'm going to show you in the next slide. Here's what we're looking at. So let's go through here first. We turn the key on. All the whites mean that we should be able to run those tests this key cycle if we meet the criteria, except for evap. It's blocked out. Down here, we drive it. Everything, these two run. VVT oxygen sensor heater run. Evap is still disabled. And these two have not run yet, this key cycle. So we either need more driving or we have a problem. Okay, so we got to look a little further. Here's a Toyota. Turn the key on. Everything is ready to go, even evap. But evap won't finish until the engine is shut off because this is a key off pump type system. But it is enabled to run all the evap tests right off the bat. So this is telling you you got a good start. There's nothing in the PCM that says we can't run these tests. Okay, now here's the Nissan that you're going to see when I tell you, if you see a Nissan that says disabled, start it up. If it still says disabled, just run it a while. And what you'll see in this particular car, at 2 minutes, over 2 minutes, the O2 became enabled. This was not the way it was supposed to be written, but I see a lot of Nissans this way. Then as you're driving, it's now enabled, and look at what happened to the O2 over here. 23 minutes later, this is a long time for a monitor test run, but that's the way these Nissans are. The O2 completed. So PID 41 tells you the status of the monitor test for this trip, and PID 41 enable disable tells you on the surface, can you run it or can't you? Typically, they're not supposed to do what you see here. Since 2019, they're not supposed to be able to disable them and then bring them back. But you could have another condition where, let me show you this one first. This is the evap. So this is a Toyota that when you turn the key on, it reports as complete. So this means overnight the pump system ran. So when I started up, it updated and said that the evap was now done. So when you have a key off system, you got to turn the key on, start it up, and have it update. Now here's the one I want to show you. This is a GM I was battling. We just got it. He got it smogged the other day. We got him through it. I'm going to collect the final data today. And you can see right here what's happened is we were driving this vehicle. O2 heater had run. BVT had run. I'm driving on the freeway, and I can't figure out what's going on. Well, there was an issue with this vehicle, and what happened is, as we got up to this cruise right here, the PCM didn't like what it saw, and it disabled both of these tests. When I saw that, it was shut it down, go back to the shop. And he has since fixed it, and when I get into the other classes, I'll put this together as a case study, kind of a cool one. And the fix was something you guys are doing. One of them you're doing regularly, and the other one's something we've forgotten about, but I don't want to give that away yet. But it turned out to be a very simple thing, and he had been battling this for quite a while. He was on the end of his, he paid his fees because he couldn't get through a smog. He called me up. We dealt with it. In a matter of time, we had this thing fixed. Okay, part 2 of the drive cycle plan is patience. There is no tool out there that will force these monitors to run while you're driving the vehicle. Yes, VW, Audi, Porsche, a long time back, you could run them in the bay. But that was the only tool that I know of that ever forced it. Anybody who says they can get monitors to run to their tools is telling you a lie. I hate to say it, but that's it. Just remember, each monitor is going to have a minimum amount of time before it'll run. Most monitors will time out after a certain period of time during the trip. I use about 15 minutes, but as you just saw that Nissan, I know in those Nissans I can drive them longer, and that O2 will complete as the one showed in 23 minutes. So you've got to develop a feel for this, and you've got to develop your own little memory bank when you're doing this. And one other thing when you're running monitor tests, when they're not running, and it seems like they should be, jump back to pending codes in mode 7 in global and see if a pending code has popped up, because that test may have run and failed, but since it's a 2-trip code, you need a second trip to turn on the light. So when things aren't working, periodically pop back to pending codes and see if something has happened, because that means that test did run, but it failed. Okay? It's just a little clue from experience. Here's one I captured off Chrysler, minimum 2.8 minutes, maximum 13.9, which means if we go to 14 and a half minutes, 20 minutes, we were done at 13.9. Test is suspended. We're not going to run until the next key cycle. The unfortunate part is most manufacturers will give you a minimum, but they won't give you a maximum. So you got to kind of draw your own conclusion. This is feel. I used to use 15 minutes. Then I started running some of these cars like that Nissan, the Nissans where I run 23 minutes. Now I got to know the car and I got to kind of expand it out sometimes. Okay, so unfortunately, nothing is standard here. This one here I'm going to run through very quickly and show you what I meant by warm-up temperature, warming up the cat. You all know this. You've done this. Look at the blue box, throttle open time. That's you. If you see this little arrow, we got to get rid of that arrow. We got to get in that window. When that arrow is gone, that is telling the PCM, when these two arrows are gone, that the exhaust is heating up and we should be getting ready to run our O2 test, our CAT test, and in Chrysler's case, their key off O2 heater test. Now you're driving it, and I purposely did this so you could see. And all of a sudden, you got to slow down. So let's say you slow down and you speed up. Well, once the throttle opens again, the timer will pick up. But if you're lazy on the throttle or you have to stop for a long period of time and close that throttle for a long period of time, once that arrow pops back up, you can either go back up if you haven't exceeded the maximum amount of time, or you're done that trip. This is what you would do to say, hey, the exhaust is hot. The PCM does the same thing. If the exhaust is cooling down and you see the global CAT temperature dropping, then you got to wonder, are we cooling this exhaust down? Are we wasting our time? Should we shut it down and restart it? Now, those videos are also on my YouTube channel. You can get them through my website. Okay, drive cycle, steady throttle. Most cases, for most of the monitor tests, a steady throttle will do the job. But there are some cases where you don't want a steady throttle. I'll show you a couple examples. Deceleration fuel cutoff events for the rear oxygen sensors. That's why you might have some problems with some Fords. You might have some problems with some Nissans. We need fuel cuts on the rear O2. Multiple rhythmic accelerations and decelerations for some with air fuel sensors. I'll show you these. And idle CAT checks for oxygen storage. So I'm going to skip this one right now. This is on the website. You can take a look at that. Here's a quick one on the CAT monitor. This is HP Tuner. I love the tool. It allows me to combine the readiness status with the PID. So I can put my enable criteria up here and I can see exactly what triggered it. So let's watch this one real quick. It's going to be a pop-up over here. It's going to say the CAT complete. I'm driving the car. I'm recording it. I got my criteria. And all of a sudden I'm done. Okay? So let me come out here. There I am, done. And what I use this for is this is how I develop criteria. I put this in my memory bank. I save this file. I know this vehicle. This is the criteria I need to run it. And if we timed it out, it wasn't a long period of time, but it's nice to be able to see the PIDs and the criteria together. So prep peace of mind with scan tools. Here's the other one, rhythmic up and down. This Toyota used in the early days of air fuel sensor. I've helped people with F-150s that had problems that these vehicles needed a rhythmic up and down. We need enrichment. We need alignment. We need enrichment. We need alignment. We don't want to be jabbing it. We don't want to be punching it. We want to be steady with the throttle, up and down, usually about 9-10 miles an hour, no more than 100, couple hundred RPM change, just rhythmically. If you're doing this on some of the smaller high-revving four-cylinder engines like Toyota, my recommendation is if you're up at 50 miles an hour, when you do this decel, hit the overdrive button. That will pull it down faster. You can get this done in a matter of minutes using that technique and be back to the shop before you even knew it. Just be careful when you're doing this on the freeway that somebody's not on your rear bumper. But generally 35 to 45 or 40 to 50, that's the window. Just variation, light up and down, trying to enrich it, lean it, but without overdoing it. And this is the one I was telling you about, the Nissans. A lot of people, I get a lot of calls on this. A lot of people have been looking at this video. This is HP Tuner again. Watch right up in here. It says oxygen sensor incomplete. It's going to take quite a while to do it, but I'm going to run this for the sake of time. We don't have that kind of time to do it. So I'm driving it. We're going through, the top box shows you all the driving conditions, throttle, speed, RPM, airflow in the middle one. And all of a sudden, we're going to get out here, and notice what we had right here. We had a good deceleration and then an enrichment by the PCM, and at that time it completed the rear O2. So it ran it really lean, and enriched it, and looked for a fast rise. So if you get in any of these Nissans that the rear O2 is not complete, this is the first place I look. Then they have another issue that we're going to adjust in the third case, where a lot of the V6s are not running and they have an issue, and we've notified CARB on it, and we're hoping they're going to look into it, because a lot of people are having 20 problems with the Nissans around the 2020 year of not completing O2s. And the information I'm going to give you over these 3 classes, we're going to show you how to use this information. So decel fuel cut. Here's the decel fuel cut. There's the enrichment. O2 is done. Okay, so again, real quick lesson. We're crash coursing this, but you'll get enough out of this today to be more than dangerous. GM idle catalysts. They've been doing this for a long time. When we've driven it 5, 6, 8 minutes, got on the freeway, maybe we come off the freeway, notice what happens. We go ahead and we go lambda, very lean. We go to open loop. When we go very lean, notice what happens to the O2 sensors. They all drop. Then shortly after that, the PCM starts to enrich in the mixture. As it enriches the mixture, we're still in open loop. We don't want to correct. You notice how the front O2s go up, and the rear O2s slowly slow the depletion of the cat. Even though this one looks a little rise here and this one looks a little more steady, both of these pass with flying colors. I would not go and replace a cat because this one rose that fast. I'd let the PCM judge it. But this is what a GM idle catalyst will do, and sometimes it'll do it multiple times per key cycle. Okay. Emphasize to you is, this is why I don't like driving patterns, cold startup. Things run in different order. Here's a Toyota that I graphed it, and this was a cold startup. This took me the time to get to the freeway. Then I got to the freeway. Before I got to the freeway, the VVT ran. But once I got on the freeway, notice the cat ran, then the O2 ran. And we're going to talk about that a little bit later briefly. And then the O2 heater right here ran at cruise. Okay? Now, the same vehicle pulled off the road, sat for a few minutes, maybe 5 minutes, started back up, got on the freeway, and went the other way. Notice what happened here. Okay? This is a little video that's running. I'm going to speed it up for the sake of time. There's the VVT. Oops, that's the same video. Here we go. Here's the second one. Now I'm already on the freeway. I'm going to stop that a second. If you notice right here, I'm on the freeway. I got right back on the freeway. When I did, the VVT went right away. The cat ran first at cruise. The O2 ran second on this slight deceleration. And notice what happened over here at idle. The O2 heater ran. So that's why I don't want you to get locked in the patterns. I want you to think about what your objective is and think about how that O2 or that test might run, and don't get locked into a pattern. I've got a lot of these, and you'll see that trying to use the pattern is not always the answer. What was the startup temperature? How long had it been sitting? Did you start it hot? So that can affect it, okay? Then we take a look at this one here. This is a common one we see, test complete for cat, but not for the O2. And I can't tell you how many times I've heard since 1996 people doing this on forums and stuff. So, oh, it's the O2, replace the O2. Only in 1% of the cases, and those are those Nissans I'm talking about, where I found the O2 to be in a state that it needed to be replaced. If this happens, I'm telling you, 99% of the cases I've dealt with, the O2 is going to follow. It is going to complete. And that vehicle did. Now, why is that? Here's the HP tuner, and here are all the O2 tests available front and rear on that car, on this GM. These are the tests of what we call flipping the flag. So you've got all these tests to be run, but unless these tests run, the O2 will not finish off. And notice, response on the front ones is one. Slow response on the rear ones is another one. Delayed response means you're decelerating fuel cut. There's another type. And you can see here the other's bank. And again, slow response bank 2. So you get enough of these tests to run. They run, and then the computer goes down the list and says, check, 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 check. Oh, the O2's at this point. Oh, the cat criteria came up. There's enough O2 information over here to go judge a cat. They'll go over and judge a cat, and then they will come back over to the other side, and whatever one of these tests in here for that car is needed to finish it off, that's where the decel comes in. So like that Nissan I showed you, the cat ran first. Then I needed a delayed response to finish it off. the other tests, O2 tests had already populated. And again, I'll show you that in mode 6 in the next class. So when you hear of a parallel monitor, it means I can go down one list, move over to another one, come back to the original O2 and test it off. I don't have to finish all the O2 tests to judge a cat. And that is quite common out there. And please do not go replacing O2s for that reason. Also, and don't replace converters and things like that because the test didn't run. You didn't meet the criteria. Don't replace the cat because the test didn't run. Let the test run and let the computer judge it. Otherwise, you're just throwing parts at it. Now, this one is on my website. You can take a look at that. It's also on my YouTube. I think it's important you take a look at it. It shows you how the O2 can show complete on some tests, but then the cat is done, and then it comes back and finishes the test. I'm skipping this one for time because we're going to be short on time. I know you guys got to get back to work. Tips for running them. This is my common thing that I share with everybody. I get calls all the time. I can't get this monitor to run. No, you can't get this readiness flag to set. There's monitor tests that you can't get to run. They say, yeah, but it worked with my scan tool. Well, here's what happens when you use your scan tool. Notice the 3 things: input, criteria, process, output. When you use your scan tool, this is your input. You're bypassing what the computer uses to run the tests. So make sure when you're judging this, judge it as a whole, but at least through the scan tool, you know that 2/3 of the puzzle works. So here's what I like to say is, ask yourself, let's say it's the EGR. Does it work under normal conditions? And what I mean by that is, let's say the typical EGR, you have to meet certain criteria, warm-up criteria, speed criteria, load criteria to get it to operate. You're accelerating the car, you just look at your scan tool and it says EGR is commanded on. Okay, that's non-readiness. We're not really testing it at that time for readiness. So you drive it, and you notice you can't get it, and we'll end with a case study on this to show you that. You can't get it to go. But at least you know it works. So what you're missing is the enable criteria to finish it off to check for performance. Okay? And flow. EGR, purge. You get in your driver's seat. You're wondering if the purge works. You rev it up 2,000 RPM in the front in your front seat. You look at your scanner. The purge opens up. The FTP drops. You know the purge opened. You know you met the criteria to open the purge. And the FTP, which is a reporting component, if you take away anything from this class, always ask yourself, what is the reporting component for that particular monitor? And in EVAP, it's the FTP. We know for the cat, it's the O2s, front and rear, air fuel sensor, oxygen sensor, could be air fuel and air fuel if it's a Toyota. But those are the reporting components. If they're not working right, then you may not be able to run the test. So you got to run the verification to make sure that they're working to a point. So I call this non-readiness. So let's take a look at this case study to finish this up. A good buddy of mine in Waukegan, Illinois, they're a centralized testing. They don't test the cars, they only repair them. And he got this car given to him from another repair shop that the vehicle had failed the smog and it needed either the EGR or the EVAP. For you California guys, there are states that use any one incomplete allows the vehicle to pass. So he was going to shoot for the EVAP, but the temperature conditions weren't right, so he went after the EGR. Well, before he got it, somebody had to replace the linear EGR and the map sensor. Now remember, that's the reporting component. So he put a new reporting component in. He put a new valve in. After multiple attempts, he couldn't get it. So he sent me some snap-on captures, which we analyzed. And this is the left-hand side of the screen. This is what we call the non-readiness mode. The EGR is working as designed. What it's not doing on D-Cell is it's not checking it for flow. Must be a reason why, but there's no counts here to check it for flow. So we go to the next page. I look at all the enable criteria, what I call enable criteria. Everything looks good. Now I go to the reporting component. And remember what I said, the reporting component is the map. And here's my map sensor on deceleration. Here's my map voltage on deceleration. I want you to pay attention to these close hashes, and the height of the map sensor voltage is well over 1 volt. Something's going on with the map sensor here. It's not the map sensor, it's a brand new one, but something's going on with this map sensor right here. And that's the reporting component for the EGR to run its test and to verify it's working. So we go a little further, we blow it up, and you can see all this hash on the map sensor, especially after a D-cell. And so we're going through this data. We're looking at our field trims. Our field trims are a little bit skewed on the long term, short terms in the window. So I'm running this by my good buddy, and we're going before this. We're talking about this. And we're thinking, geez, on deceleration, where could I have that kind of manifold pressure change? The car runs great. Lo and behold, what we came up with, we told him from 2,000 miles away to put a PCV valve in this car. And he did, and look at the pattern on the bottom. The voltage pulled down under a volt. Everything looked good here. The hash was cleaned up, just a $10 PCV valve. And now we ran the non-readiness mode. Now we went into decelerations, and every time you see these bumps, those are deceleration, those are samples, the testing is going on. So if you know these vehicles, the PCV valve is located just below the map sensor. So it's very sensitive to, the map is very sensitive to what the PCV valve is doing. That's exactly what I'm working on in this Silverado. What wound up fixing this car was a PCV valve and cleaning the map because of the vapors we're getting up in there. So my point here being is, ask yourself, does it work normally? If the EGR is not open at all, then you're not going to run the readiness test. You're going to run other tests, and it's going to say, hey, EGR, there's something wrong with it. It's not even opening. But if you can see it opening like it is on this left-hand side of the page, you met some criteria to make it work. The question is, did you meet the criteria to make it test? Those are two different things you got to take out of this webinar. Did I meet the criteria to make it work? Did I meet the criteria to make it test? Okay, two different worlds. Some cars, they might do it exact same time. Example, Toyotas, when you accelerate at EGRs, they tested it on the first acceleration. Not only did it work, but they were testing it specifically for flow, for temperature rise. So make sure you're asking yourself that. Okay, to finish this up, again, this is the vehicle when it's all done. You can see on D-cells, when it was supposed to test, now it's popping up the EGR and taking samples. In next class on mode 6, we're going to talk about this averaging. We take little samples so the customer doesn't feel it. We average it out. We pass or fail the system. We weren't getting this before because the map wasn't dropping low enough. $10, fix the car, plus labor. Okay, last thing. Things to think about. We could put the hood latch on this now. I hadn't had that till recently. If a vehicle is a truck, make sure it doesn't have an extra load on it if you're trying to run monitor tests. Is a vehicle operating temperature? Absolutely critical. Got to get up to operating temperature. Have tire sizes been changed? If it's pre-can, can you believe the fuel gauge? Can you believe the fuel gauge? Can you believe the sending unit in the tank? Is it vibrating? Transmission problems, diesel truck tuners, unsupported monitors. Somebody went in and turned them off. Non-factory electrical devices, too much alcohol in the fuel. And I'm sure if we queried this whole group, we could come up with probably a bunch more on here to populate this list. So takeaways, have a plan, get your conditions. If you don't have your conditions set to use existing freeze frame. Remember, published drive cycles are nice, but they can work out of order. Temperature startup temperature changes them. Verify these important PIDs and enable status, a key on engine off, and verify there's no conflicting DTCs. Now, obviously, you all found this workshop today through Delphi, but I do want to let you know on May 21st, we're going to do a follow-up, building this into the last class of Mode 6 operation. I hope you can join me. Be another hour on that. Here's the link for that. And in June, we're going to finish it up with Mode 6 and complete these together with some case studies and things like that will help you pull all this together, make you a better repair technician, and hopefully save you time and makes you some money. So for today, if you need me, you can reach me through my website. Feel free to do that. Happy to help you here. I thank you for joining me, and I look forward to seeing you or having you participate in other classes. So for today, I thank you. Have a great day, and I will hopefully see you in a month or two. Thank you. Bye.